Hey AJ, how you doing?
Yeah, good. Thanks, Luke. How about you?
I am good, thank you very much. First day back after Christmas and a New Year break, so excited to get this recorded with you. Did you have a decent amount of time off in between
It
the
was
Christmas and New
nice.
Year period?
Yeah, it was nice. Thanks for asking. I definitely had a nice quiet one. For me, I needed a bit of a break after a busy few months. So it was great to get some time off and take it easy and not have to think about coming into work and also, you know, being able to spend time with my family. And yourself?
Good. Yeah, similar to yourself, last year was quite an intense year, I think, for everybody in most areas. So I definitely appreciated the break, a lot of relaxing, and just spending time with my little one, as I mentioned previously, and now ready to kickstart 2024. I just can't believe how quick time's flew, really, hasn't it? Like it's feels like
Yeah.
we're only off for 2 days rather than a week. But okay, well,
Yeah.
just so for our listeners today can understand a little bit more about who they're listening to and yourself, do you want to give a very brief introduction to yourself?
Yeah, sure. That sounds good. So my name is AJ. Look, we've spoken before, but I'm the deputy head of Powertrain Advanced Systems at Lilium here in Munich, Germany. I have a background in mechanical and electrical engineering. I grew up in Australia, but I do a lot of different things on a day-to-day basis. At the moment, I run the propulsion and the custom electronics departments as integrated project teams. I'm providing the main leadership there.
Fantastic. Okay, great. And then just to jump in, let's start the podcast the normal route then, getting personal, the first section. Before we get into just talk about the career, I always like to start with like who are you outside of work? What do you enjoy when you're not working? Even though I imagine that's rare with where Lilium at the moment and the journey that they're on at the moment.
Well, yeah, exactly. No, that's a really good point. I think we talked about this before. At the moment, I've got a lot of different responsibilities, wearing too many different hats. It's only because it's crunch time, and this year is the year of delivery for eVTOL industry in general, especially where I work. So that leads me to not having a lot of spare time, but I do use the time that I do have. At the moment, I'm practicing being terrible at skiing. So skiing is a new hobby. I grew up in Australia, so snow sports weren't exactly a big hobby of mine, but I'm trying it now because I live in southern Germany and I'm not far from the Alps, so I get a chance to give this a go. Apart from that, I like older cars. Personally, at the moment, I own two Mark One MR2s, which were from one's an '86 and one's an '89. One has been converted to electric and currently lives in my parents' garage in Australia because I don't want to sell it. The other one I've got with me, which I bought in the UK when I was working in London for another eVTOL company. And that one is here with me in Germany. I'm currently going through the process of converting it for German historic registration so I can drive it regularly. So I've got that. And, travel is a really big hobby of mine as well. So I really enjoy taking the time off. Being in Europe, I have the fortune of being having quite a good work-life balance, so that gives me opportunities to travel. Actually, one of the things I did over the holidays was spend some time planning all my holidays for this coming year, because it always goes so fast, as you mentioned, and I don't want it to get away from me. And last year, I felt some of the weekends it got away from me, and I didn't get a chance to plan it properly before they came around. And yeah, I mean that's me now. I still do the same things. A long time ago, I had hobbies riding motorbikes, but then now I'm a little bit older and a bit more sensible, but still enjoy it.
If makes sense. Okay, great, fantastic. Passions. Do you have any particular passions or hobbies that think would be of interest to our listeners?
I think that's a really good question. What I do for work is my passion, and if you ask me what I would do if I wasn't working, I'd probably do the same thing, but for no money. A big aspect of that is, I think, fundamentally the core of it is that I had a passion for solving problems at a very young age. I just wanted to fix things, and usually that started with me breaking them in the first place when I was younger. So I always had an interest in aircraft. I grew up in India and Australia. I was born in India, then moved to Australia when I was 9 years old. But when I was young, my grandfather and now my uncle lived in a house right next to a military airbase. There used to be Sukhois and MiGs flying sorties about 10 or 12 times a day, even after hours, and even sometimes late at night, midnight or past. So I used to just watch them. I was at the end of the runway, so they would always come in with afterburners on. And as a child growing up seeing this, it was just magical to watch this. And I used to spend most of my time there sitting on the roof watching the planes.
Wow.
That just naturally became part of what I do for a day to day. And I tried to get into this industry in Australia as well. And the technology and the idea of flying was always interesting to me. Being a pilot, it's one thing that's on my list of things I will always do. But I'll get to it eventually. Maybe not this year, soon enough. But as a result, I love everything technology related, and I like automotive and aerospace. And at some point, I was in Australia, working in Australia, running my own business, and had to move to from Australia to Europe for more opportunities in space because things happen at larger scale here.
Wow, okay, fantastic. And what's really exciting to hear and great to hear there is obviously the passion you had as a child and doing it is now what you moved into as an industry, and probably is one of the key reasons, only reasons why you probably excelled so well in doing it, hasn't it? If you can find your passions and work in the field you love, they always say the saying is it doesn't feel like a day's work. So, yeah, fantastic and very
Yeah, yeah,
interesting hobbies there that have transferred over into
yeah.
what you do.
I could probably add just one point to that. It's probably related to the sustainable technologies and why electric aviation. And that was my passion because it was something I picked up at university. I used to race solar powered cars as part of the World Solar Challenge and the American Solar Challenge, and building cars with teams and racing them across the continent really ignited my passion for the electric aspects because I was always interested in the automotive side. I was always interested in piston engines, jet engines, and powertrains from that perspective, but quickly recognized that the future of aviation and automotive was electric. So, and that was also in my interest. That's how they put together as aerospace and electric.
Which also connects back already to the car that you turned into electrification Australia, isn't it? So it's that hobby from just
Yeah,
combustion engines or aircraft engines to now in the more modern world, the advanced technology that moving into the electrification side, which you had, which is fantastic and yeah, very, very interesting hobbies, no doubt.
yeah,
Moving on to our next area then, which is one of my personal favourites, is a bit about your education. Like, what did you do before you ended up in the industries you worked
sure.
with today?
Yeah, sure, sure. So I have to start with a caveat by saying some of the people I work with are incredibly qualified, and in this cohort, I'm a bit of an odd duck. So I've got a bachelor's in mechanical engineering. I studied at Western Sydney University in Australia. I had a really great experience in studying my mechanical engineering degree there, but I wasn't very focused on. I wasn't a very studious person. I can put it that way. But I worked on a lot of projects. So I was always doing extracurricular things, either building solar powered cars for years. I think 6 years I spent doing that. Then there was always cars and motorbikes on the side, or projects related to robotics or tinkering on drones and RC models as well. That was more towards the end of my time at university. Now I got a chance to really develop my skills in engineering and learn the theory, but I also applied it, and I really felt I walked out with an education rather than just a piece of paper. And I think that was a really important point that I would like to highlight. Through these experiences, I got to apply it in the World Solar Challenge. The highlight for me there was going to the USA, racing across from west to east, and beating incredible universities and coming first in that competition against uh, private and university teams like your uh, typical universities that compete are MIT, Cambridge, Stanford, Michigan University, etc. And these kinds of universities, for somebody who grew up in Australia and Western Sydney, was an incredible opportunity.
Hmm.
After this, after this, I worked on setting up a business with one of my peers from the Solarcard team, but we'll get to that, I think, a little bit later.
Yeah, great, and obviously great success there. And obviously, the solo car competition is one of an example of actually there's fantastic competitions, isn't it, across university level that cover this electrification field. And yeah, certainly the fact that you built that car in Australia and then competed in America alongside, as you said, MIT, Michigan, and eventually did one is definitely an outstanding achievement. And yeah, fantastic show of just how good that course or that opportunity is the solar track. And yeah, I certainly never heard of that. We'd mentioned today, I'd heard of others, but yeah, what a
Yeah,
fantastic idea and place to be. Once you
yeah,
got your
yeah.
degree and once you're pressed and you're ready to make that move forward into the industry of working, how have you ended up in the aerospace industry, or why do you think you've chose the aerospace mobility industry?
Well, it's a good question. I described earlier how I grew up next to an airbase, and it actually impacted me a lot. I wanted to go into either space or aerospace. I was really interested in doing any type of work in the aerospace or even launch vehicle industry. Now, those opportunities were pretty thin on the ground in Australia. So, what ended up happening was I got involved with drones, and I saw a colleague of mine, a peer of mine at the solar car team, was working on drones, mostly racing drones. And at the time, he was trying to make them bigger, and he was also working on some of the key electrical aspects like motor control.
Hmm.
He was wanting to set up a company, so we got together and I helped him with running this company on a day-to-day basis. We essentially grew it. It was getting really interesting because we got to talk with and actually supply components to a lot of tier one aerospace companies. At the time, I would say we were more orientated towards being land, sea, and air, so covering all
Hmm.
the domains because electrification is possible in all the domains. And
Hmm.
actually, submersibles have been electric for a long time. And they're, as you can imagine, where do you let out the exhaust underwater? So there was a big drive as well to have these electric components there. And then from an
Hmm.
aerospace industry, you'd be surprised that the aerospace industry is very similar to a lot of others. From land and undersea submersibles, what you find the safety critical aspects are quite similar. But
Hmm.
the aerospace industry has the most mature way to design safety critical components. So I naturally gravitated towards it because it's difficult and it's very
Hmm.
difficult. So now we worked on drones. Everything gradually got bigger, and my personal interest, as well as I said before, it followed exactly on this note. I wanted to do military aviation, so I took the company down this route. And even now, it's a military aviation company primarily orientated around defense.
Hmm.
And essentially, things got bigger and bigger and bigger. And before I knew it, uh, starting from DJI Phantom, we were powering eVTOL aircraft up to 4.5 ton using
Wow.
components we designed ourselves. And we naturally became like a tier two, tier three type supplier. So now that was across Australia, Europe, and North America. So
Hmm.
I was working weird hours, and I was always, as I mentioned earlier, I was always interested in engines or propulsion systems in general, and putting these two things together resulted in a company that was really interesting, and that was the start of my interest in the aerospace industry and a continuation and now into the eVTOL industry as I transitioned from just making components to actually designing the vehicles and then running departments who are designing the vehicles.
Wow, which is fantastic. And one thing I want to highlight here, which is very, I think, interesting and unique, is the fact that yeah, you initially ended up due to coincidence when you're from that running your own business initially before going to work in the future for the OEMs or the tier ones that you've gone down that
Yeah,
path with, which is typically the backwards way that
yeah,
people do it. But
100%.
the experience there is great, and from running the business to go into that field, it's fantastic. And then you've
Yeah.
obviously acknowledged previous in our conversations that early experience across the solar, and then having your own business, you think has made a great impact that's allowed you to progress to where you are today, aren't you? That we'll cover in further detail.
Yeah, I think to really drive that point home, you're absolutely right. I often describe it to other people who ask me, "Why did you do it that way?" And I said, I do tell them I feel like I did it backwards compared to most people. The reason I ended up this way was purely because of opportunity and the timing. Um,
Hmm.
as you know, the industry has exploded over the last few years. At the particular time in the middle of the 2010s, we were working on drones, and everything was getting bigger. There was a big hype around delivery drones, so there was a lot of money and research interest in the industry. And this was, for me, it's an opportunity and timing thing that I got a chance to really take a risk on this. I was also looking at the same time at options in the urban mobility space, more like last mile transport. So I looked at basically the option
Hmm.
of designing with a local science business park that was being built in Western Sydney. They were spending $1.5 billion on this project. I was talking with them, and actually, we were considering to the point of a feasibility study of setting up a autonomous pod transport service, which is similar to like the Navia vehicles. And actually, I was
Wow.
looking at designing my own vehicle to do that because it was a very short step from the solar electric vehicle that we designed at university to then add some autonomy or path following functions to that. And essentially, I ended up realizing that if there was anywhere these new technologies would be deployed first, it's kind of backwards as well. It would happen in aerospace first. So I think we'll get onto that a little
Wow.
bit later.
Okay, so which is interesting and press to do. And also, I suppose, pressing back to some of my experience and knowledge of obviously with Australia, at the time you were doing it, Australia for engineering typically previous years hasn't had the largest amount on doing it, but I know that there's actually big changes in the way Australia are agreeing contracts now, aren't they? So in the future, it definitely will become an engineering hub with the agreements they have in place. But it makes sense why you've had to transcend to Europe and America for now. But it'd be really interesting to see in the future. Because from the outlook looking, I think Australia will probably be one of the next booming engineer hubs of the world. But we can discuss that on a
Yeah,
different
yeah,
day.
yeah.
Um, okay, great. So once you're in the space, and then you obviously you decide, okay, aerospace is the place for yourself. What's led you to develop a career in it? What's led you to go from running your own company to where you are now?
That's a really good question. Actually, even my first boss, when I left this company, asked me that question: Why would you come from running your own company to come and work as an employee? And I think it's a really important question to ask because it really is talking about intentions and what I wanted to do. One thing I realized that working in my own organization in a small team, working on some incredibly difficult problems as a supplier, there was only ever two outcomes. One, that I did a really good job and I would never see my customer again. And the other option was that I did a really bad job and I would never see my customer again. So if I, number one, if I, one thing I realized is that if I really wanted to see the, a project to its end, which is something that I was personally really interested in at this
Hmm.
stage of my career, then I would need to join the OEMs and I would need to start at the vehicle level so I could work across the entire V cycle of the development. So from initial concept all the way through to into service. And that's why I've ended up where I am today. And actually, I've taken a few steps through a few different eVTOL companies. I've worked as a supplier and even in the company for over 10 eVTOL companies so far on their
Nice.
propulsion systems. That's been super interesting because every single place has had a different culture. I've worked with some in Asia, for example, and that was very different to the ones I work with in Germany, and even the one I worked on in the UK. As well as the approach that I took in the USA when I was traveling over there and also working for a couple of companies there. So I guess the answer is that I saw that the industry was growing. There was a lot of demand for it, and there was incredible interest in developing this capability for the commercial applications in eVTOL in the eVTOL industry, so urban air mobility, so moving people and goods from place to place. And as a result, it was natural for me to grow into this industry, and also it felt natural for me to with my interest in going across the entire V cycle, to focus on management and to develop my interest in not only propulsion systems but how best to approach them in different companies.
Nice, which when again obviously relates back to the career development, but the passion of a child of always loving aircraft and engineering, isn't it? They're coming hand in hand, and
Yeah,
I like the fact that you saw the opportunity in the space, but which also must have been perfect for you because you were going, well, this is what I've always loved to do. So almost
yeah,
couldn't have
yeah,
a better match for you, which is great. Okay,
yeah.
and then which is a fantastic overview to where you're now, which is great. Thank you for that. I suppose for our listeners on the section for those achievements, is there any particular key achievements or highlights of your career that you're particularly proud of, or you think could be of interest to our listeners?
Sure. I think this I can keep it quite simple. There's a lot of specific examples I can go into on key achievements, but the way I can sort of put them all together is to explain that I'm really proud of the fact that every place I've been, I have left feeling that I've left it better than I found it. And I think that's a really important aspect to what I do on a day-to-day basis. That's what makes me feel satisfied with how I work and actually being able to provide or improve the place that I'm at. And when it comes to the impact there, I feel my strongest impact is on the people. So my key achievements are to have made an incredibly diverse network of individuals that I believe are extremely competent and be able to work with them on a day-to-day basis. And frankly, to pick up the phone and call them for advice as and when I need. For me, the network and the technology that I've developed in each stage has been incredibly valuable and is a key achievement that's only grown with time. And
Mhm.
I feel at the moment I'm doing the best at it because the best yet at it because I'm in my biggest opportunity so far.
Nice. Okay, fantastic. Any out of those fantastic things you covered, is there any particular highlights or anything at all that,
Yeah,
on a component or product level, might be something you'd be
sure.
able to share?
Yeah, yeah, absolutely. I can give some general statements, because of the kind of some of the work I've been doing. It's funny. Most people you'll talk to in this industry, you'll find every single person has two-way confidentiality agreements. So generally,
Of
I have to be
course.
I have to be a little bit careful, but I can say these things. I thought about this earlier when you asked me, and to make sure I got it right, I can start from university. So my experience in university was racing solar cars across the outback, and the USA, building and leading these teams, and then finally culminating and winning a competition in the USA, breaking a 20-year streak from another team was an incredible experience for
Wow.
someone who I personally, I've always felt like a little bit of an underdog, which is why also I really enjoy what I do on a day-to-day basis. It's about exceeding expectations. And I believe that our industry is capable of doing that too, but I think we'll talk about the industry later.
Hmm.
When my next point was, I truly trusted a peer in the Solarcon team. To forego a normal job and just getting a job in any other company and to build a deep tech industry making aircraft components in Australia. We couldn't even get
Hmm.
insurance at the time that we started. We were working out of this little corner office that looked pretty dodgy in southwestern Sydney, and we were powering some really interesting aircraft because we were pouring everything we were making into development, and he was doing it for years.
Wow.
Now, in the process that I was building products, I was building teams, and it felt like I was building the industry as well. Because, for example, one really interesting one I still follow to this day is Cinelifters. What they are is drones that carry payloads about 4.5 kilograms. And they're capable of accelerating to 200 kilometers an hour in less than 3 seconds. So the kind of
Wow.
power requirements and the transient behavior that you need to design around for this type of aircraft was extremely interesting. And I mean, I don't have to go far to say that you can probably imagine another application that's potentially not commercial where that can also be used.
Hmm.
And I was saying it for years. Involved in defense industry drones for almost 7 or 8 years now. I was saying it to my defense industry colleagues that drones are going to be an incredible force to contend with, and nobody has a solution to this. Counter
Hmm.
UAS doesn't work, and we were talking about all of this well prior to the Ukraine war, and a lot of things have been deployed in Ukraine that are relevant as well. But I had some other pinch me moments in that company. I was in a working group at NASA Ames. We were discussing the future of the eVTOL industry. While it
Hmm.
was in its nascent stages almost 7 or 8 years ago, the people I had the pleasure of being in the company with have been incredible at each stage of this process. But I remember talking with a gentleman who ran the X-Planes program, and we were talking about the X-57, and he gave me some numbers on how he had calculated the eventuality and likelihood of electric aircraft in different categories of aircraft over the next 50 years. And we were talking about how they did an internal study about this. And I would have never had the opportunity to do these kinds of things if I wasn't involved in the eVTOL industry. So, I mean, a few other things, if I may extend a little bit, Luke.
Of
Sorry,
course. Of course.
I had a small but surprisingly impactful experience at a local startup in Sydney, designing and training aircraft for the Australian Air Force. Those are now in service and were deployed. I was only there for 6 months, but in 6 months, between the three of us, we designed and built a sub 2 kilogram drone that had all the functionality of the Shadow platform and even
Wow.
similar implementation. So we got a chance to create this. We procured 400 of them, and then I got picked up and moved to London to work at another eVTOL company, which was also extremely interesting. So didn't have a chance to see that through to service, but that aircraft is now in service, and I worked on the design and development from a systems engineering, component selection, flight testing, and everything in a very lean way. I can describe it. Without much resources and learning what corners I can cut and can't cut. And I think doing it in reverse has helped me with that a lot in understanding how to approach a complex problem with limited resources that you often don't have to consider in an OEM environment where you can get what you need or you have a history of what you need.
Yeah.
Then, working in London was really interesting. I developed engines for electric aircraft in a very small team. And that was 5 people, and we were every single one of them extremely competent. I'm still friends with those guys today. I still talk to them, and I absolutely love it. They're all different to me. All had great experience. One particular was a guy who's ex Formula One. And
Nice.
he for years and years and years thought the epitome of what he wanted to do in technical aspects and challenges was in Formula One, but then moved over to eVTOL, and like a lot of ex Formula One guys I know are doing at the moment, and because there's some incredible challenges in it that isn't governed by a very tight rulebook. Uh, then, yeah,
Definitely. I can definitely see
yes,
that from the talent percent doing that the opportunity within electrification because the or car commonly come first in it, and now the challenges that you're seeing in aircraft and
Yeah.
marine, and some of the challenges sometimes there's not enough people as background. So there is definitely a movement, people coming from those industries, because it's similar principles but different challenges, isn't it? And typically
Yeah.
with most engineers, from my experience, the challenge, they love the challenge.
Yeah, exactly. After all this, then I jumped over to Volocopter. I
Yeah.
was there as a propulsion system owner. That was an incredible experience, being able to work on the propulsion systems and being responsible for the propulsion systems for the demonstrator aircraft that we had flying all over the world. Um, Now that's even carrying people and has been carrying people for a few years. But it was incredibly rewarding to see a team come together and then a vehicle actually be deployed and flying people that was running under ultralight certification. And then finally, now, right? I mean, my most interesting highlight yet. I mean, apart from the information you can find publicly about what we're doing at Lilium, but I feel incredibly fortunate to be able to work on an incredibly challenging opportunity, like to shift the paradigm in mobility as part of a team that's extremely capable and really are doing a good job being resilient. Because the industry is difficult, as you know, and often there are a lot of skeptics,
Hmm.
and rightly so.
Like
People are
with anything
skeptical, and
new, and with anything new as well, people don't like
exactly,
changing the
exactly.
yeah.
I experienced the same in the drone industry as well. Military aviation was exactly the same, and yeah, I mean it's similar, but now even more exposure because of all the public aspects of what we do. But yeah, that's I'm really looking forward to the next highlights. I'll have some great ones in the next couple of years, I'm sure, as
Yeah,
will
no
the whole
doubt.
industry.
No doubt, and also a very, very interesting career to get to where you are. And you've done a lot in my interpretation in quite a short period of time. And yeah, it's been a very exciting space in the eVTOL field. And yeah, once again, I think it all just comes back to the passion you have for what you do is something that, yeah, I think has been a key aspect in allowing you to succeed in the
Yeah,
areas you've been. So section four, then learnings, which on most podcasts is probably my personal favourite, because I think it's where our listeners and myself, I definitely get the best learnings from, and the best understanding from. So question one of that, like if you were to look back at your career, what are the key learns you've learned, or the key things you've learned that you wish you probably knew when you were 18 or 21 that you
yeah.
feel would have give you an advantage on a younger self?
Yeah, that's again a really good question. So, Luke, I've learned a lot, and engineering is a team sport. That's something I've really learned innately. So, I guess the way I could break it down to into bite-sized chunks is to divide it into three areas. Managing people is one of them. Then the second part is technical, and then also how does the commercial aspects of what we do fit into it. So I mean, there's this fantastic podcasts and information and books about from a gentleman named Simon Sinek, and he always talks about starting with why. And this is really important because from the perspective of what we do on a day-to-day basis, it should flow from why is this actually needed, and then we can talk about it from so engineering being working in teams. Ultimately you're doing something extremely complex like designing an aircraft, and you can't do that with one person.
Hmm.
You're talking about multiple disciplines with people with very different approaches, different cultures, different backgrounds, and lots of diversity. And this is a really beneficial thing to designing any type of complex system, because the different opinions and different peers that you work with can provide the review that you need to ensure that you've considered as much as you possibly can before you go to test. Now, the aerospace industry is designed in a way that we verify what we do before we ever allow anyone to operate in it. But what that means is that, at least in the development process, that we can utilize the teams to actually to work through it, the key challenges, and actually inform our problem statement correctly, and then to check that we've completed the work. So, I mean, that's the managing people part. So really, don't undervalue the managing people and working in a team. So
Hmm.
team sports I did after extracurricular or even part of my engineering activities, like those very frustrating group projects that we all have while we're studying. And when I definitely had plenty of those when I was in university, those are
Hmm.
extremely valuable and added a lot more value than I expected. Then I mean, the technical aspects is key challenges in the industry that I wish I'd known sooner and probably would give myself advice if I was starting again now, would be related to the electrification aspects of mobility. Now,
Certainly.
all of those aspects are extremely important, and learning particular skills in those areas will bode really well and serve anyone who's considering this industry really well now. Aerospace creates a certain challenge when it comes to the safety and the certification aspects, because you are developing ultimately components or vehicles that need to carry human beings safely and achieve these 1 in 1 billion hours sort of reliability rates, or random failure rates. You need to consider all of these aspects in the design of your components. So learning how this works together is something that wasn't traditionally taught in university,
Hmm.
but extremely useful. So that systems engineering and safety engineering mindset, as well as linking that with working with people to make sure that we're all on the same page, and ultimately pulling it together with a why is it important, and how does the commercial aerospace industry impact us and in the decisions that we take on a day-to-day basis. Perhaps some of the assumptions that we have coming in are because we're used to operating a vehicle in a certain way based on historical evidence of heavy fuel aircraft for the last 60 years, but maybe that's not correct. And that's why I
Hmm.
really enjoy what I do, is definitely be able to challenge the status quo. Work on the
Yeah.
technical aspects to understand the key technical challenges for aerospace, which is definitely electrification, and then
Hmm.
from a engineering being a team sport is how I would sum it up.
Fantastic, yeah, and a great piece of advice there, certainly, that I don't think many people would be aware of, especially because they're all learns you've done from actually working in the industry, haven't they, really, rather on the theory based. All those key pieces of learn sounds like it's come from experiences of working. So yeah, I think real good piece of advice there, and any of our listeners, I think that would be great for them to take note and try and do as much research as possible as they can to get ahead of the curve now, although
Yeah.
I imagine it might be difficult.
Yeah, well,
Okay.
yeah, I just wanted to follow that up. It will be difficult, but I feel in many ways engineering is not is more of an applied science rather than necessarily focus on invention. So if you take
Hmm.
that approach to you and as an individual, if I took that approach with myself as an individual, I would tell myself that there's no point for me to make all the mistakes myself. It's better to learn
Hmm.
from other people. So
Yeah.
so there's definitely a lot of information out there that we can learn from. For example, there's some fantastic courses that are open. There's one I can think of as a suggestion if it would help. MIT Open Courseware does a fantastic course in aircraft systems engineering, which is
Okay.
basically how to develop an aircraft system. And it's a very old course with the recordings being really old, but they're fantastic because the people teaching them aren't just lecturers; they're the people who actually applied them on the space shuttle. So the
Oh
lecturers
wow.
are so the people who did the work on the space shuttle, which is the genesis of the ARP 4754A, which is the systems engineering and safety framework we use on a day-to-day basis.
Hmm.
The genesis is from there, and the people who actually applied and used them then taught a course 20 years ago, which is now freely available to us. Why would you make
Wow.
a mistake twice?
Fair. To be fair, what is one thing actually I have to compliment MIT for, even though I'm not an engineer, but on the staffing side, a lot of what I've learned around the field time is that MIT give course. So I know definitely on ADAS and stuff like that. I've spent hours watching their videos on YouTube and then trying to break down the terminology. But yeah, that's a compliment, and yeah, fantastic piece of advice there actually, that there's free capability online to develop in these
Yeah,
areas. And and the key point here, which you've reiterated throughout our conversations, is that it's a team sport. To develop any
yeah,
of these complex solutions, you've got to be comfortable with working in teams. If you want to lead teams, you've got to understand how to motivate people differently and press that to build a great culture along all those points there. So yeah, fantastic learns. Um,
yeah,
Next question, I suppose, which is probably up there with my favourite, for being honest, is if you could go back to yourself, your younger career, but you only had 30 seconds or a 45-second window with yourself, so you
yeah.
ultimately going to give yourself one piece of advice, what would that golden nugget or that one piece that you would offer be?
Sure. If I, yeah, I'm going to give you a few cliches if that's all right. And I'll start.
That's
I'll
fine.
start. I already gave a shameless plug to companies I'm not even affiliated with MIT. But basically, learning from wherever you can, as much as you can, as frequently as you can, is extremely important. I mean, I already mentioned that in my previous statement, so I won't say that again. But keep learning. Number one, it doesn't end with university. Then the next point was a quote from a comic with Mark Twain's statement. And I don't even know if it's a correct statement, but it's resonated a lot with me for the last 10 years, and it will for the next 20 years. So the statement is simple. It's 20 years from now, you'll be more disappointed by the things that you didn't do than by the ones that you did. So throw off the bowlines, sail away from safe harbor, catch the trade winds in your sails, and explore, dream, and discover. And this has
Yes.
really resonated with me for years. I mean, for me, what it means is from get out of my comfort zone. And I took years before I got out of my comfort zone. I was always
Hmm.
challenging myself. Like right now, I'm bad at skiing, so I'm outside my comfort zone to ski. So, but I'm learning something, and
Yeah.
I think it's really important because I think we're always bad at something, and you got to be comfortable being bad at it. And as you grow as an adult, you get less and less comfortable being bad at something because you specialize, and I think that's a mistake. So you should always be comfortable. Practice humility in making sure you're terrible at something on a regular basis, and then finally, ultimately the ultimate expression of what we do is an art form, right? So
Hmm.
engineering to its highest degree, if we weren't getting paid, if we would solve every problem in the world, it's an art. So I
Hmm.
think understand what you're doing as an art, and that art takes a long time. So have patience and understand that the first time you approach it won't be the best. But what you can do is you can rely on the learnings, or learnings of yours or learnings of others. So iteration over time with the correct inputs of maturity and knowledge and wisdom is going to get you much, much further than the ultimate talent and brilliance of being one very smart person only once.
Perfect, yeah. And another fantastic point there, which I love, is it's the continuously challenging. If you're not good at something, don't avoid it. Try and always put yourself in that uncomfortable position so you're comfortable at being uncomfortable, and that continuous strive to learn and develop. Because just because you can master one area, actually, it's better
Yeah,
to keep trying to learn, develop. And I love that point there because definitely. Um, in previous times, I don't know, from my experience, and you might disagree with me here, I don't think the culture was the same with that. We always be pushed to specialise. I didn't want to be a master of that one area rather than now with the leaders I'm speaking to, like yourself, that's done very well. It's that continuous desire to learn, but also that happiness to fail and always that wanting to be comfortable with being
yeah,
uncomfortable at something, which I think is a fantastic piece of advice for any of our listeners there, definitely. Um,
yeah, yep.
Last question in this section. If you could look back at your career, is there anything that you would change or you might have done differently in hindsight?
Sure, yeah. I think I was, yeah. This is a question I thought about a lot, and from my perspective, I wouldn't like to say I regret anything I've done, but
Hmm.
it's important. There's one aspect that I think is really really critical, and that's to focus on being a T-shaped person as soon as possible. And when I say T-shaped, it's something we look for in the organization I work for now as well, and I'm really glad that they acknowledge the importance of it. It's the value of being broad in your knowledge as well as deep. So you
Hmm.
must, it's really a lot of value. Say, for example, I'm an engineer, right? And very early on in my university days and high school days, everything like that, we were always told, you must specialize, you must specialize, you must specialize. And actually, I think now looking back, I wouldn't have done that so early on. And I'm glad that I didn't, because basically what it resulted in is me focusing on the general skill sets that I needed to be competent in all areas of my day to day, and then specializing in one area in propulsion systems. So
Hmm.
I feel I did that okay, but I could always have done that better because sometimes I was looking in very wildly broad areas in different industries. And so a little bit more of a focus would have been nice in this particular aerospace industry. But
Hmm.
I can only say that being as hindsight is 2020, and so it's the only way. Actually, there is one more piece. I would say have patience. I would definitely do that differently because I was always told, and we've had a lot of in the last 20 years, we've had a lot of really incredibly successful people who've come out of university, and there was this almost idolization or fetishization of dropping out of university and becoming a billionaire overnight. And
Definitely. Yeah, definitely. We've seen some of those success stories.
exactly, and it was when I think about it, when I was younger, it was always shoved in my face, and I can imagine even today, it must be shoved in everyone's faces that you must be the most brilliant engineer in the world or the most brilliant business owner in the world 2 years outside of university. And no, I
Hmm.
felt that pressure, and I felt this
Definitely.
mad rush to try and do that. And actually, looking in hindsight, there was no point. Actually, the best thing to do would be to have patience and understand that a career is a marathon and not a sprint. And I wish I would have done that. I would have focused more on that.
Certainly, which is obviously another fantastic piece of advice. There are some examples of some stories where people press on doing it, but they're actually very, very rare if you actually look at the general population success. So yeah, if you do are fortunate to do that, then fantastic. But also yeah, you've
Yeah.
got to have the patience to understand, especially in the highly technical engineering fields that you and our other guests are working within. I think the chances of what you've just discussed happening is probably as rare as winning the lottery, I
Yeah.
suppose. So, great piece of
I,
advice there. Definitely remain patient and plan for the long term rather than
yeah.
quick turns around in success, which is, yeah,
Yeah,
great.
I can, I can give you a relation in the aerospace industry. So when we design a system, we start with a very probabilistic approach. This was what I said was derived, or the genesis was in the space shuttle program of a statistical approach to safety, which is the ARP 4754A or
Mm-hmm.
4761. And we have this number 10 to the minus 9, which is purported all over the industry. What does that mean, right? And ultimately, what I'm trying to get at is if you have a bell curve of behavior, and what you're looking for is to essentially be as close to the middle of the bell curve as you can. And when
Mm-hmm.
it comes to most people and the way they operate in the industry, you'll find that it's better and more chances of success, and you actually prefer the system that falls into the realm of understanding and inside the statistical likelihood that you expect, rather than necessarily focusing on the edge of the bell curve or the outliers. Whereas when we talk about these billionaires or starting a company and turning it into $100 million company overnight, these are just statistical outliers. You don't design a system assuming that'll happen. So in the same way,
Fair.
don't design your career aiming for that.
Fair.
So that's, yeah.
And a fantastic engineering breakdown as well, which I will definitely note. Next section is over to you, and this is the part here is where we like to give our guests the opportunity to discuss a particular topic in the industry or something they're passionate about, or just to go in more depth of a piece of advice that they have. Ideally, just to make the podcast more unique for each guest. But I suppose from your side, what topic or what area are you looking to discuss today?
Sure. Yeah. We talked briefly about this when I actually summed it up as the importance of theory and practice. Now, something I learned very early on. I mean, I could talk about a lot of things like diversity and inclusion, the value of doing different things in the industry, as well as having very different hobbies. But
Mm-hmm.
for me personally, what's really affected me and what's really helped me a lot in my career so far, something I could speak to as my personal experience over the last 15 years, is the value of the hobbies. Um,
Mm-hmm.
and from my perspective, like you can see me, I'm sitting in my little room at the moment where I have a little office space where I get a chance to tinker on my own things. I've got a 3D printer and some soldering stations here. I can rework boards. I can make things. I can
Nice.
design things. I've got a bunch of electric motors and ducted fan components on my desk as well as behind me. Um, and even some RC planes and drones in the corner. And I just wanted to highlight these and put these there actually deliberately because my room was a mess before you called. Um, and basically the reason I bring these up and I have them in the screen is because they're really important. And at the end of the day, what it's helped me to understand is the holistic view on how I approach the decisions that I take on a day-to-day basis. So nobody explains to me how to do my job or what I need to do in my job. They'll explain to me the why, right? And ultimately,
Mm-hmm.
that's how I like to drive the team as well, where I work, and that's how I like to be driven as well. Um,
Mm-hmm.
the best thing for me to understand is how does my decision that I take affect someone else or something else down the chain. And
Mm-hmm.
my hobbies have really helped me to understand that. My hobbies have also helped me working on cars and motorbikes from a very young age. I remember when I was in school, when I was supposed to be studying for an English exam the next morning, I was putting together an engine for my Kawasaki ZXR 250 in my bedroom. My mother was horrified because it was my final. I think they're called A levels in the UK, right? So grade 12
Yeah, they
exam.
are. Yeah,
Yeah, that's right.
definitely.
It was my university entrance exams, and I was busy putting together a motorbike instead of studying. And it was always for me. I feel that added a lot more value for me because I learned how other people approach problems, how do things go together, and
Mm-hmm.
not just how they go together, but why did people approach these things this way? And this was very meditative and also very like helped me to understand not just the theory, but also how is it applied. So then I could challenge the things I learned. One really good example of this, if you want to see a very cliche way to look at this, is there's a fantastic comic called The Knack by
Yeah.
Dilbert. So there's a very short video. It's only a minute, but it really summed up and made me laugh. My mum sent me that when I was younger and said, "I think this is you," and she's absolutely right. I was always pulling things apart and putting them back together again.
Which is interesting, obviously, on the engineering side. Definitely, that's the probably one of the key reasons or the definitions probably for your success, I suppose, in the sense from that young age you've always had the passion of you've done the theory throughout your education. Obviously, you've passed on the exam capability side, but actually implementing that theory or actually just taking things apart when you're studying that theory to understand how that works has probably been a key thing for you that's allowed you to success. So, which is really highlighting, yes, the importance of theory, 100%, but we also need people, you have that mind where you continuously practicing that theory or breaking things down or seeing how that works in the real world, don't you? And you probably say that's one
Yeah,
of your key, I would say personally, reasons or USPs that you've done so well in your
definitely.
career in a period of time. And then going back to Preston on that there with your degree, which
Yep.
is the theory side, but with the solar panel course, did that come as a part of your degree? Was that like literally something that like an extracurricular activity you could do from university, or did you just stumble across that yourself?
Actually, yeah, it's a funny situation. I wanted to join the Formula SAE team. I eventually did join the Formula SAE. We built student race cars with motorbike engines, and that was
Yeah.
that was natural for me at the time anyway. But I also wanted to join something a little bit more high profile. At that time, it was a solar car team. It was its
Okay.
first. It was its first instance. So as part of the founding team, we well built the team. We got the budget from some from the university, some from sponsors. Basically, operating like a small company inside the university
Wow.
to raise the funds, which is about at the time it was about 300,000 Australian dollars, to design and build the car, then put our friends in it, and actually get them to drive the car across the outback while we're supporting them with on the road with all sorts of other traffic. And that competition essentially is a really exciting competition. One of the
Hmm.
I would say a really challenging engineering competition, which isn't mandated heavily by a rule book, so you're not constrained. It's a very tiny
Hmm.
rule book, so there's a
Hmm.
lot of flexibility in the design and the way you operate compared to Formula SAE. But it gave me it gave me a real chance to make the mistakes, so I wouldn't make them with my own money, if that makes sense. And
Of course, yeah. But
yeah,
it just the implementation, the practicality of that, and we did there definitely was the early jumper on the
yeah,
career alongside with the theory. So it's just your
100%.
highlight again that theory, that practice, that implementing it, doing any more
Oh
courses or
yeah,
any events like the solar thing and the
oh
growth
yeah,
that allowed you to have is a key
yes.
thing we'd be recommending to any of our younger engineers.
And definitely, that was a big part because I actually took too long to finish university because of this competition. I took a year and a half extra to finish my degree because I wanted to do this competition. I took that year and a half off university so I could focus all my time on it. And at the time,
Wow.
it wasn't part of my university, so it didn't contribute to my degree in any way, but it added a lot of value for me personally, and I saw that.
And went alongside with the passion there from your side as well, the enjoyment
Exactly.
of doing it, of breaking it down, and fantastic, and has played a key part, which is great. So yeah, fantastic cover there, and the overall push we're trying to push there is the importance of understanding the theory, but also the practicing. You've got to break these things down. You've got to have a passion to understand how these
Yeah.
things work, so you can see what's been done previously to try and improve them while implementing the theory, which I think is fantastic. Yeah, overview there. Um,
Yeah.
Next section is technical tips. So what we like to look at here is if you could look to the future or the market, are there any areas across either the EE or mechanical technical spectrum that you recommend people either specializing in or being aware of because it's going to have such an impact on the aerospace or the field you work in?
It's a really good question. I mean, I'm really biased because of what I've done so far in propulsion systems development. So I'm going to focus on electrification for my advice. It's also the only area I feel qualified to speak about as well. I don't want to take anyone else's opportunity there. I only want to say that if you're focused on electrical engineering or electronics engineering, then developing control systems, specifically motor control, power electronics, half bridge. Sorry. Uh, Pretty much inverters is where I would be spending my time. And that's what I
Hmm.
see now as hugely valuable. And if you're focused more on mechanical engineering and you're biased towards the more mechanically oriented disciplines, then I would focus on thermal engineering aspects because ultimately the maximum weight you can lose on an aircraft is driven by your thermal mass. And where you can optimize your thermal mass is an understanding of your thermals and fluids. These are
Definitely.
these are these are very complicated topics in university, by the
Definitely.
way.
Yeah, of course. No, definitely. Well, yeah, on the staffing side, doing that. Obviously, there is a huge demand. Regardless, there is definitely a skill shortage in these spaces before even just specialised in the aerospace field. And I imagine the reason for that is that they are some of the most challenging areas within across not just aerospace, automotive. Those same pain points that are there.
Yeah. Additionally, to add to your point, it would also be that they're underrepresented in traditional aerospace. That's a
Okay.
very key point, and it's key point because traditional aerospace doesn't need to focus on control systems like motor controllers as much because you just don't use them in safety critical applications in most cases. And similarly, thermal engineering is more oriented towards heavy fuel type aircraft. So how do you best design a turbine for cooling? But that's relevant, but not the same as electrification.
Of course, but now is that obviously these areas are growing and have been growing a lot more because the change in the approach or the solution has
Exactly.
moved away from what the historical solution has been for many years with electrification, with new fuel energy forms
Yeah.
coming into these skill sets, which is an interesting point that weren't as common are gonna or well, are common are growing more and more in the space as we enter these new approaches. But okay, great.
Exactly. Yeah. Yeah.
And I certainly know from the spaces I'm doing it, there are two areas that I think at any point everyone is always looking for the talents and growing to do. So fantastic recommendations. Section 7 is industry outlook. And what we look at here is, from your viewpoint here, like what is up and coming in the industry, or what are the key areas that are going to impact the aerospace or future mobility industry, in your opinion?
Sure, that's a really good question. So, one thing I'll start by saying by explaining a little bit about the eVTOL industry and why it's important. So, at least from my perspective, the opinion I've held for years is that we are at a very unique inflection point in the aerospace industry. That there's only been a couple of these really major paradigm shifts before. One I can really describe. One I can give an example of is the jet age itself. So, conversion from traditional piston engines and rotary engines to our jet engines in the 60s and how that birthed commercial aviation. So we're at the precipice of this happening again in the eVTOL industry, with the eVTOL industry, sorry, as the driver. Now, what this means is it's a very unique time where everyone is on a level playing field, and which is why it's
Mm-hmm.
almost a competition or almost a race. In many ways, if you look at it from the outside perspective, it looks like a race, but from the inside perspective, it's a very long and arduous grind to solve some incredibly complicated technical challenges. And
Mm-hmm.
those challenges, you'll see over the next year, you'll see the industry taking off quite literally with the aircraft going flying. Some of our competitors from the companies that I work in are already flying demonstrator aircraft. But
Mm-hmm.
in the case of Lilium, you'll see that through the publicly available knowledge. You'll see that later this year. Now, when
Nice.
it comes to by end of next year, you should be expecting all of the OEMs to be flying aircraft, and everyone will be able to see this clear with their own eyes, which is, I think, going to be a very important statement for these aircraft to have, um, well, to disseminate across the industry for people to see it as an
Definitely.
option.
Definitely. And
Uh,
when people see it, they start to believe it more, don't they? That's a big pressing point
yeah,
there, which I think will improve that growth.
100%. And then naturally, the next skeptic will come out, which is the person that says, "Well, I can see it, but I can't access it because it's not affordable for me." And I think that's a natural. There's a law basically that transistors are going to double in speed or half in cost every 2 years, right? And
Hmm.
this is also going to be applied to true technology, and definitely this logic applies to the aviation industry. And you'll see this in eVTOL as well. The first time to do something is always the hardest, and in many ways, what we're doing is, and I speak specifically about electrification here. In many ways, what we're doing hasn't been done before, and that's what
Hmm.
keeps it really interesting. Then, shortly afterwards, you'll see a lot of focus on autonomous vehicles.
Hmm.
Now, autonomy is something that actually, for the last 10 years, quite literally hundreds of billions of dollars have been poured into
Definitely.
automotive OEMs for autonomy.
Hmm.
Although it's been very difficult to achieve true level 5 autonomy as per the NHTSA chart of autonomy. Actually, one of the things that I chose to do very early on in my career is to focus on aerospace, because I see that as the first place where autonomy will be introduced, because you have a
Hmm.
very controlled and constrained environment that's very difficult to achieve in land-based vehicles. You might
Certainly.
get some idea of that from sea-based vehicles, but aerospace is a fantastic opportunity for ADAS systems or autonomy systems to be developed. So you'll see a lot of that very soon.
Hmm.
Some companies are already working towards it, but it's difficult because there is no rule book. How do you best approach it? There's no answer. So there's only approaches that are being studied often in PhD type arenas, but then application is often a different story. And then
Definitely.
ultimately, we can talk about electrification. But I think you know lots about electrification. But to go back to that one point earlier about speaking with the gentleman who was responsible for the X-57, um, having that conversation with him, and the numbers that they crunched in the X-Planes team, saying that the earliest occasion in which we'll have commercial airliners flying electric is 2070 due to the development of batteries, for example. But that doesn't mean that we haven't considered a different way to fly.
Of
Short
course.
haul being more achievable and comparable to train network. So I think you can talk about the cost of infrastructure. For example, for an electric aircraft, the infrastructure requirements are quite low. We're talking about in the order of $5 to $10 million for a vertiport, at least in my experience. But when it comes to a train line, you can spend 25 million euros per kilometer for a train line. Now, how many aircraft will that buy you, and how many routes can you service if you have an entire network or hub and spoke approach for your electric aircraft design? And how efficient will that be? These are the things that will fall out of the industry processes in the next 2 to 3 years. So we'll truly see product market fit and whether we can change the paradigm of mobility in the next couple of years.
So it's a very exciting time to be involved, and obviously loads of different ideas and theories coming through. Some with fruition, some may not in the future one day. But yeah, the changes, the impact of this craft when it's proven, the potential of it is definitely vast. I certainly agree with you on the shorter haul flight capability. Obviously, there's many positives for that around CO2 and different costings on doing it. It's been a very exciting couple of years in the space anyway, but I only feel we're at the beginning of that journey, and when the infrastructure starts to be created, it's the expansion which I'm personally very eager to see. We always like to give the good and the bad, or the potential bad. Is there anything that could currently negatively impact the sector or have a negative effect on the sector that might stop or impact these growth?
Sure. Well, there's a lot of skepticism around the industry, right? And I think that's natural and very much acceptable and expected for the industry that we operate in, and the difficulty of what we're doing. Often people would look at it as being, say, out of reach for the regular person. But I want to definitely state that part of the job that we're doing is to try and democratize it. So when I say democratize it, what I mean is making it a achievable a reachable standard for most people to travel. And I think that one of the things that is really hurting everyone in the industry is the cost to develop these technologies, and the amount of time it takes to develop these technologies. And people know it, So for example, the difficulty in not having all of the rules set out in the beginning, it's been an incredible challenge to not have a clear picture of what we need to do. So sometimes you might have to do things multiple times and in different companies for you to really find the right technique. But everyone has been fighting with this for years. One of the reasons that I was over in Ames was because we were talking about the standards. What's the right way to design a propulsion system for an electric aircraft? There is no one way.
Of course.
And while that makes it incredibly challenging, that's impacting the entire sector, we've come a long way in the last years. We've now got standards that actually define how do you make sure that another gentleman with my responsibility or knowledge in another company is rating the aircraft in the same way that I would rate it. So how do I make sure that I have X amount of hours of flight, for example? So these are all really difficult problems that are impacting the whole industry. We're finding solutions, but we haven't solved them yet, and we're still working through them. So we'll see that. I think also some other aspects is it's always difficult when pretty much everyone is working on incredibly complex technologies, and we should be sharing them. So the learnings that we have is genuinely going to benefit everyone. So hopefully we can start to use that a bit more by learning from each other, or utilizing our networks to solve the incredibly complex problems without letting business competition get in the way of progress.
Of course, yeah. And these challenges are, even if separate countries develop in separate countries, they are global challenges, aren't they? Definitely. And if they're quicker it comes together to doing it, it's all solutions for everyone in play. But the fact they're global challenges always creates further potential needs, which might make the solution slower or the pressure on doing it. But I think the ultimate idea here is that we are making serious progress. We have made serious progress in this field, and it's not if, it's just when, in my opinion now, especially in the eVTOL space.
Definitely. I think we passed that the point of no return a while ago, that critical point where now it's become a when. One of the other challenges, like to associate that, is the difference in approach. Europe is using a special condition VTOL, which is a special set of rules for these type of aircraft, whereas the FAA is using a powered lift category for all their eVTOL aircraft. So these aircraft are not comparable like to like. They're different standards. Of course. So it's hard for most people to understand that. And I think apart from being very deeply involved or knowledgeable about the regulations, most people wouldn't pick that up.
Yeah, of course. And certification, as we've hinted at earlier in the aerospace, is probably the most difficult to get certification for the criticals on doing it, which is always creates further challenges in a way for us to manage to get these things certified, which is great. Okay. Um, why aerospace? And what I always ask my guests to look at here is obviously the engineers you're looking at most of the time with the skill sets you need would be able to go into automotive, consumer electronics, medical, semiconductor. Why do you personally believe that aerospace is, or eVTOL and aerospace is the place these engineers should be looking?
Yeah, sure. That's again a really, really good question. Now, when it comes to aerospace specifically as an industry, because it's the most driven by safety critical design. So in this industry, that you have to be extremely careful how you approach a design to be essentially available 100% of the time, or as close to 100% availability as you can get. Now, what this means is that the system design is as robust or resilient as you can possibly get from most industries. We use this term development assurance levels to define how to approach a system design, or the level of criticality it has, or the level of rigor you need to apply to a development process to get this done. And that has been always very interesting to me because in the applications we do it for, I'll give you an example, right? So commercial aviation compared to say launch vehicles. If I was designing a rocket tomorrow, so a rocket only has to pass through the commercial aviation aerospace, the aerospace, what's the right word for it? The airspace. Sorry, I said it wrong. The airspace, commercial aviation airspace, it only has to pass through that for a few minutes. Whereas a commercial aircraft, you might have 10,000 of the same type of aircraft flying for 2 hours a day over 10 years. Now, the
Mm-hmm.
amount of hours you do in those aircraft, and each aircraft flying 10 people, you've just moved, tens of millions of people. So now,
Mm-hmm.
what is the likelihood of failure? You don't get this level of scale in any other industry. You don't get it in launch vehicles today. You,
Mm-hmm.
you don't get it in anything that is as safety critical. And in automotive, for example, you don't get that either, because in automotive, if you're designing ACLD products, you need to make sure that the safe state of your device is open circuit, or puts the driver in a safe position where they can pull over on the side of the road and step out. How do you do that
Mm-hmm.
in an aircraft? You can't do that in an
You can't.
aircraft. So you can't pull over in the local cloud. So you need to find a way to design these incredibly complex systems that are available all the time to make sure you're protecting human life. Ultimately, that's why aerospace is interesting for me. And then I can talk
Definitely.
specifically about eVTOL. Now, in eVTOL, why I'm in eVTOL versus any other section of the aerospace industry, it's because there's no proven solution to the problem. So
Nice.
because we haven't converged on a single design that meets the requirements of everything, so we aren't all designing cigar tubes with wings. We have the opportunity. We have the opportunity to try different things, and I think that's very exciting, because that's for example, if I talk to a lot of engineering friends who went in or have come from Formula One, they went in there because they got to push the edge of engineering, absolutely the bleeding edge of engineering, and work on incredibly complex problems where there wasn't just one solution to the problem. And actually,
Mm-hmm.
to me, that's happening the most in the eVTOL industry and the drone industries today.
I can agree with that at the moment. Definitely, for the last recent years, it's definitely the most innovative field from my outside looking in. Definitely.
Yeah, it's a real juxtaposition, right? It's an area we can take the most risk, but that's also the most risk averse.
Mm-hmm.
So,
Which, and obviously, from experience, what of speaking of engineers, that's most of the time where most engineers like to be, don't they? The passion of innovation, the passion of these new products and areas. And in your viewpoint, at the current time, eVTOL and aerospace is that place to be. And then obviously the
yeah.
impact this technology can have on the human race is so enormous as well. That's another key driver for you personally and most engineers in my experience. So, yeah, I think that's a fantastic answer. And if I had the right experience to be in the field, I think I would be looking at the eVTOL aerospace field, especially on the electrification front, just because the challenges that you guys are on to overcome and still will have to overcome in the
Yeah.
future, because you're all pushing for the generation one of an aircraft as well. Let's not forget there's going to be other generations that follow that need to improve. So a fantastic space to be. Okay, great. Well, fantastic. And I suppose apart from that, like, thank you very much for your time today, AJ. Really enjoyed recording this with you. Some very interesting points, raising some ideas. And as I've said, I really like the fact that you've almost done your career backwards. You're definitely the first people in your position I've seen that had their own business before they've now worked for an OEM, but some real key insights. And yeah, thank you very much for getting behind the incentive. And it's been fantastic having you on as a guest.
Yeah, thank you very much, Luke. It's been really great to talk with you. And so far, talking about this has made me think about what I do in a really deep level of detail that I haven't had a chance to do in years. So I really appreciate it.
Perfect. No worries. Well, thank you very much for your time. All the best in 2024, and no doubt we'll be catching up again at some point. But just, yeah, thank you again for your time.
Sounds good, Luke. Thanks very much.
Thank you.